Welcome back to episode number 11 of this tutorial series / crash course on ROS2. You can find the series playlist in the description. And let's get started. So in this tutorial, we are going to create a service client with Python. And to see what we need to do, let's actually come back to the application with the turtle controller that we have. So let's run, so ROS2 run turtle sim with turtle sim node. Okay, we have the turtle here, and then we have the controller, ROS2 run turtle, my package, so my robot controller with turtle controller. So for now, what we have is the turtle is correctly controlled to move around and not hit the wall. What we want to do is we want to kind of split the screen in two and say that on the right, we want the color to be, let's say, red, and on the left, we want the color to be green. So the color of the pen, all right? So we wouldn't want to modify the color depending on if the turtle is on the right side or on the left side. And how can we do this? Well, ROS2 service list, we have just actually used, so this one, the turtle one set pen service. So we have just used this one in the previous tutorial to explain what are services. And so that's the one we are actually going to code. So we are going to code a service client inside our turtle controller so that we can modify the color of the pen depending on where the turtle is. Okay, so let's actually do that. I don't need to create any new node or anything. I can just go back to, so let's go to the source folder of the ROS2 workspace and let's do code dot, and let's go back to the code. So the turtle controller here, and so that's where I am going to create the service call. And where are we going to create the service call actually? Well, we are going to call the service from the pause callback. Okay, because we need to call the service depending on where the turtle is. If the turtle is on the right of the screen, which means that actually the pose x is greater than 5.5, which is the middle, then we're going to choose the color red. If it's on the left side, we choose the color green. And so we will need to call the service, so to create a client with a request in the pause callback. Okay. And to do that, I'm going to create a new function, here, a new method in the class def call set pen service. Okay, because we will have a few lines of code to do that, so I'm going to create a method that is specific just to call the service. Okay, and let's do self, and then let's put all the parameters we need, so RGB width off. Okay, how do I know that? Because if you do ROS2 service type with the set pen, okay, where do I have nothing? Okay, because, well, the service actually doesn't exist. I need to run ROS2 run turtle sim node. Then this should be better. And ROS2 interface show with that. We have RGB width and off. So those are the 5 parameters of the request. So I create a function and I just send this as the parameters. And then what do we need to do? Well, we need to create a client in the code. So client is equal to self. So self is the node, create client, as simple as that. What do we need to provide? We need to provide the service type. What is the service type? The service type is turtle sim srv set pen. So we are going to do from turtle sim dot srv. Okay, we did msg for messages for topic, and here for service we do srv. Import set pen. Now we need to make sure that we have the dependency to turtle sim, but we already added it before. Okay, in the package.xml we have turtle sim, so everything is good. So I have set pen that I can put here, set pen, and then we need to provide the service name. All right, so very similar as for topics. For topics, we need to provide the type and the name. Here we need to provide the type and the name. What is the name? The exact name is this, with quotes. It's gonna be better. Okay, and that's it for the creation of the client. So now we have a client, but well, actually we have nothing. We just have an object representing the client. What we will do is we will say, let's say we want to wait for the service. Okay, we don't want to call the service if the service is not up. Because if you call the service and the service is not up, well, you're gonna have an error. Here I'm gonna do while not client wait for service. So you have this wait for service method in the client here that you use with create client. And we need to provide a timeout, let's say 1 second. And here we're gonna do self.getLogger. We're gonna log something, and instead of info, I'm gonna use 1. Okay, 1 is gonna print something with the yellow color. And let's say waiting for service. So we do wait for service for 1 second if the service is up. So this is just gonna return immediately and we can continue. But if the service is not up, after 1 second, we're gonna print waiting for service, etc., etc., until the service is up. All right, now we have a client. We know the service is up. What we can do, we can create a request. So let's do request is equal to set pen dot request. So actually request with an uppercase and open close parenthesis. And then we are going to fill the request. So request dot r is equal to r. Okay, that's gonna be what we get from the parameter here. And then request dot g is equal to g. Request dot b is equal to b. Request dot width. All right. And the last one, request dot off is equal to off. So we just repeat the parameters inside the request. Nothing really fancy here. And then, well, we're gonna call the service. Okay, we have the client, the service is up, we have the request. Now we can call the service. So we can do client call async. So this will call the service in an asynchronous way. What does it mean? It means that it's gonna return immediately. If you call it just with the call like this, it's gonna call the service and then wait, so block right here until the service has replied. But if you do that, you may have some problems with the different threads, okay, with the spinning, and I'm not gonna go into much details here, but if you block the thread that's calling the service, you may have some errors, for example, that the response is never received. So I'm gonna call async, and I need to send a request. Okay, so client.callAsync request. This is actually going to give me a future object. Okay, so we are going to work with future. And also I'm not gonna go into much detail about future, but basically a future is something that's gonna be done in the future, basically. So you can work on this future, you can add a callback so that when you actually get the response from the service, then the future is gonna call this callback and you can process the request. And that's what we're gonna do. So I'm gonna add here a callback, def callback. Let's call it callback setPen self, and also future here. So that's how to write the code. So here, well, I'm showing you how to write the code. It may sound a bit complicated for a service, but the thing is that it's always gonna be the same thing. So the first time you write the service client, it's a bit difficult, but then you're gonna write it a second time, a third time, and then you're gonna have written it 10 times, 20 times, and it's gonna be super easy at the end. So here in this function, let's do pass for now. And that's gonna be the callback for when the service replies with the response. Okay, we call the service, we send the request asynchronously so that this method is gonna return, and then we need to add a callback for that. And to add a callback for that, I'm gonna do future dot add done callback, and here I'm gonna use partial with self callback set pen. So I provide the callback here. And partial is not found, you need to import it. So from func tools, import partial. That's one thing you need to import. Okay, with Python func tools and partial. Then we put future.add-down callback with partial self callback set pen, and this is gonna call this method when the service has replied. And in this, what we do is we do response is equal to future, so that's the future we get here, dot result. Also, I'm going to add this inside a try and except block, because we might have a service exception. I'm just gonna do except exception as E. And if I get an exception, I can do self.getLogger. And here I'm gonna use error. Okay, so that's yet another level of logs. Okay, we have info, 1, and error. And I can say service call failed. And I'm gonna use this syntax with R here and then percentage E comma inside parentheses. So that's a specific syntax, but that's just how you can print an exception easily here with ROS2 services. All right, and now the service call is complete. So to recap quickly here, we create a client with self create client. We set the type and the name of the service. Then what you can do is you can also wait for service to make sure that the service is available. Then you create a request. You do client.callAsync to send the request to the server. And this is gonna give you a future object. Then you can add a callback with future.add-down callback and partial. You can add a callback so that the callback is gonna call when the service replies. When the service replies, you need to do a try except block so that you can manage the exception if you get an exception. Okay, so if the service could not be correctly handled by ROS2, or if, I don't know, if anything bad happens, then you're gonna get an exception and you can print the exception with this syntax. And if everything works correctly, then by doing future.result, you're gonna get the response. And here, well, I do nothing with the response. Why is that? Because here with ROS2 interface show, you can see that we have this for the request, and then dash, 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 and we have nothing in the response. So if you add something in the response, for example, with the add to int server that we have used previously, you could, for example, do response.sum, and that would be something you can use in this node class. Okay, you could use it to do whatever you want. You can process the response and do anything else you want. All right, so now we have the syntax for the service call. And this, well, basically this is gonna be almost the same every time you call a service inside a ROS2 Python node. Now, well, let's actually call this service because we have a method, but we don't use that method. Where are we gonna use it? Well, we're gonna use it in the pause callback. So what do we do in the pause callback? We get the pause, and then depending on the pause, we send a different comment. We're not gonna change that. But after we do this, we're gonna also check where is the turtle. So depending on the X property of the pause, we're gonna change the color of the pen. So for example, if X is greater than 5.5, so actually pause.x. So we know that the middle point is 5.5. So everything on the right of the window will be more than 5.5. Everything on the left will be less than 5.5. So if it's more than 5.5, what we can do is to do self.call setPenService with, so we want it to be red. So let's do 255, 0, 0, and then width, let's put 3, and off, let's put 0. And then else self.call setPenService with 0. So 255 for the green, 0, 3, 0. All right, so right side of the screen, red, left side of the screen, green, as simple as that. And maybe we can also add a log self dot get logger dot info, set color to red, and let's do the same here, self dot get logger dot info, set color to green. All right, so we know when we send the request actually. If you want, you could also add some logs in the call setpoint service and also in the callback, so in the try block, to see when you get the response, when you send the request, etc. Good, so this should work, but I'm gonna add something else because, well, now the question is how frequently this is going to happen. For now, we didn't really worry about that, but now we should. Why is that? Because, well, when you publish on a topic, you can publish at very high frequencies. For example, 100 Hertz, 1000 Hertz, that could work also. Even a few thousand Hertz, sometimes you have some topics that are published very, very frequently. But for services, a service is not made to be called 100 times per second, okay? A service is made so that it's called when you need to call it, in a punctual way. So it doesn't necessarily mean that you can't call a service 10 times per second, but the best way to handle services is just to call them when you need to. Otherwise, it can really slow down the application. So let's find out. So what do we need to find out? We need to find out how frequently we get the pause. And this we can use with another command. So we have, so TurtleSim is running here, ROS2 topic list. We have the pause. How frequently do we receive a pause? Well, that's a good question, and we can get this with ROS2 topic HZ, okay, for Hertz. That's gonna give us the frequency of the topic. Let's do this, and it's gonna listen to the topic. So let's wait a bit and let's do Control-C. It's gonna listen to the topic and then publish the average rate, which gives you an idea of how frequently you get some messages on that topic. And you can see we have about 60 messages per second, so 60 Hertz, which means that this callback is called 60 times per second. We publish a command 60 times per second, and with this code, we would call the service 60 times per second. So for a publisher, 60 Hertz is good. For a service, you don't want to call a service 60 times per second. So what can we do to solve that? Well, it's quite simple. We can, so let's use the turtle here. We can keep track of the X position, and we can actually just change the color when the turtle crosses the middle, okay? So when the turtle goes from left to right, or when the turtle goes from right to left. We don't need to change it when the turtle is left, and that stays left, okay? The color is gonna be the same, okay? We need to change it when the turtle crosses the middle. So we have two cases here. When the X position is lower than 5.5, and then the X position is greater than 5.5, or when the X position is greater than 5.5, and then the X position goes to lower than 5.5. So let's create, well, let's do that quite quickly, but let's create here self previous X, and let's just put 0 as an initialization value. Okay, and we're gonna do if. So if the pause is greater than 5.5 and self previous X is lower or equal than 5.5. Okay, so it means that before the turtle was on the left and now the turtle is on the right. Then we change to red. And then else, I'm gonna add else if actually. So not else if, but elif with Python. Pause is lower than 5.5. Actually, let's use lower or equal here. And self.previous X greater strictly than 5.5. So this means that it was previously on the right side and now it is on the left side, and then we want to change the color to green. And of course we need to do self.previous X is equal to pause.x here and also here. Self.previous X is equal to pause.x. So that's a very quick way to solve this issue. Maybe there are different logical ways to do that, but this is quick and easy, and that's gonna be enough for this tutorial. So we initialize the previous x to 0, doesn't really matter. And then when we go from left to right, we set the color to red. We also save the previous x, and we do the same when we go to the other side. So that if we stay on the same side of the screen, okay, so if we stay on the left, we are not going to call the service. If we stay on the right, we are not going to call the service, only when we cross the middle. Okay, I'm gonna save this, and this should be it. So actually, let's find out and let's try. That's the only way to know. Let's kill everything here. Clear. Let's do source -rc because I'm gonna run the script from there. I'm gonna run the controller from there. Here, let's do ROS2 run turtle sim with turtle sim node. Okay. Here we don't need that screen. And let's run, so ROS2 run my robot controller with turtle controller. Let's see what happens. Okay, and we have an error, which is this is not supported between instances of pose and float. Let's find out with the code. Yes, actually it's pose.x. I forgot the .x. So of course I can't compare a pose with a number because that's something that's different. Let's try again. So let's run this and let's try this again with source-rc and run the controller. Okay, you can see it's red and then it crosses the line and it's green, and we have a log too. It crosses the line and it's red, and you can see set color to red and then set color to green. All right, and then again and again. I'm gonna leave it just a bit so you can see what's gonna happen at the end. Okay, great, you can see it's working quite well. The turtle continues to move, tries to avoid hitting the wall, and whenever it crosses the middle line, it changes color. So you can see everything on the right is red, everything on the left is green. So everything is working as expected. And well, congratulations, you have just written a service client with Python. You have also mixed it with some publishers and some subscribers in just one node. So you have already a complete ROS2 application. Hey, it's Edward. I hope you enjoyed this crash course and that you found it useful. Now, if you want to continue to learn ROS2 with a full and in-depth course covering everything about the ROS concepts, Python and C++ code, and also more practice activities, well, I have the course just for you. This ROS2 course contains more than 10 hours of structured video content and also downloadable code for each activity and project. You will dive into the ROS concepts with much more details and also discover ROS parameters, launch files, how to write service servers, and many other things. So if you like the way I teach, check the course out. The link is in the description. Click on the link, read the course description, and decide if you want to continue. Alright, thank you for watching, and I hope to see you in the course.